lots of rules. It's hard to remember all of the rules. All right, so you have to be able to figure things out. You must be able to figure things out. All right, so I don't really care. We don't have to go in order. Here we go. We kind of ended up. Okay, so we kind of ended up on 16, didn't we?
Yeah.
Do I need to do 17?
No.
All right. Thank you. It is. All right. Yes. All right, here we go. Let's just go ahead and jump on 18 real quick. Refer to the trapezoid where x and y are midpoints. Now, the reason why that is critical is because that means that's the midsegment. And the midsegment is simply the average of the base. That's all it is. All right. So if MQ is 15 and XY is 10, you should be able to say, obviously, then NP is 5. You don't need to do the average formula, right? You're just saying from 15 to 10 is 5. You got to go 5 more if you want to stay in the middle. Everybody good with that? NP is 5. NP is 5. Listen, I am not in a mood to play around. I said there's too much going on. All right? I don't care. All right? Come on. Now, it says next, if NP is 13 and MQ is 18. Right. 15.5. Not a big deal. All right. Now it says the sum of the interior angles of an animal pen is 900 degrees. How many sides does the pen have? All right. So we would just say what?
So you would say 900 n to n minus 2 times 100.
Right. So listen. So the sum of the interior angles is equal to n minus 2 times what? 180. Does everybody agree with that? Any questions? So if I have 900 equals n minus 2 times 180, then we can all solve that. What does that come out to be? 7. All right. Any questions or concerns? 900 divided by 180 is 5. 5 plus 2 is 7. All right. Now it says a convex hexagon has those measures. All right. So a hexagon is how many sides?
6.
So 4 times 180 is. So the angles add up to 720. Does everybody agree with that? Now to me it's just easier just to add up the x's, right? 6, 8, 15, 21. Everybody else get 30x? And then if I add up the numbers, what does that add up to, guys? Negative what? Oh, okay. N minus 2 times 180. 6 sides, 6 minus 2.
Negative 200.
Is that right?
Yeah, no, it's 29.
I think it's 30x. Somebody else get 30x. She's saying 20.
I got 30x.
It's 30x. All right. So what was the numbers now?
Numbers is 200.
Yeah, Trace, oh no, I did.
Negative 180.
Is it negative 180?
Negative 180.
All right.
Thanks a lot.
Doesn't matter. Doesn't matter how you got a number. Just practice doing the mental math. That's what you should be doing. All right. And I'm asking, is that right? Negative 180.
Yeah. Yes.
All right. Now, if I were doing this, well, we can just say that's mental math, right? 720 plus 180 is 900. Yeah, 30 sides. Not a big deal. Find the measure of each exterior angle of a regular 2-hexagon. All right, very simple because the angles always add up to what? 360. So the formula is just take the 360 and divide it by the number of sides, correct? So they're trying to make something a little bit harder because they don't give you a number. So it's just 300 divided by what? 2x, which is the same as 150 over x. That's the answer. I don't know why I said 100, 300. It's 360. Thank you. So it's 180. Of course not. Right, the reason why you can't solve x is because x is just a number, anything. All right? Yes.
Okay, so I was thinking when you said like 7.8 equals 30x minus 180, but then you said the x equals the sides.
30 sides.
I thought that was the angle, like part of the angle there.
Oh, I was thinking, yeah, man, I'm way off. Listen, you're right. It's x is just, so I was thinking we were doing the one even above that. You're right. Thank you very much. It's not 30. It's just 30. No, it is 30.
One. How do you get 7
Hexagon.
6 minus oh yeah.
So the 360 over 2x, you don't need to do that, right?
180 over x.
Why? What is that for?
Okay, come on now, listen to me. This right here is how many sides there are.
Wait, we're above that.
You might be. You asked me about 22 now, right?
No, that's oh, I thought that was for okay.
All right, come on. We gotta go. We got a short day. All right, lots to do. All right, the measure of angle 1. Yes.
75.
All right, lots of ways to do this, correct?
Yep.
So what we can do is, if that's 31 degrees, because it's a parallelogram, the alternate interior, so that's 31. Everybody agree with that? And if this guy right here is 96, we could do the quickest way is to say 96 minus 31, which is what? 65 degrees, right? Because again, that's an exterior. The exterior adds up to the remote interior. All right, if you didn't like that, you can just subtract from 180, 96 from 180. Is everybody with me? And then that would be what? 84.
And then vertical.
And then you could add them up. Okay, so look, let's refer back to a couple chapters ago. This angle right here is always equal to those two angles.
There's
Right.
angles added there, right?
That's what I said. So x plus y equals z. X plus y equals z. That's just a quick way. Well, I looked right here. Come on. The exterior angle. Come on. Stop. You guys, I'm not interested in the back and forth. All right? I don't care what the question is. I'm in a hurry. That's part of the reason why I'm making some mistakes, because I've got lots to do. I don't need any extra. This right up here we said was 31. This is the exterior angle. This angle plus this angle equals 96.
Oh, okay.
Number 24. ABCD is a parallelogram with diagonals that intersect each other at E. Now, in my opinion, I would draw out ABCD just so I could see, so I don't make a mistake. All right? Because I think lots of times they try to mess you up with the shape. So I draw the diagonals and I put E right here. I think that's what it says. Yeah. Yes. So then AE is x squared, and then good, EC is 6x minus 8. So what's true about AE and EC? They're equal, good. So this is a good little review of algebra. X squared minus 6x plus 8 equals 0, factoring x minus 4, x minus 2 equals 0, so x could equal 4, or x could equal what?
In the back, it's like 8 or 32.
Because they want to find all the possible values of what? AC, not x. You see that? Again, I'm just telling you, you don't, I wish some of you are learning the hard way, that if you don't answer the right question, right, on a multiple choice test, they're always going to have x equals 4 and x equals 2. Do you understand that? and then you're going to think you got it right. Instead of going back quickly and just looking at what the question is. Because the question could say, what's AE? Could say, what's EC? Could say, what's AC? Everybody with me? So if x is 4, what's 4 squared? 16 times 2. So AC could equal 32, correct? And if x equals 2, 2 squared is, times 2 is 8. So it could be 32 or 8. Agreed? Anybody have any questions? All right, for quadrilateral ABCD. So again, on this particular case, they're just saying it's 4 sides, nothing in particular. The slope of AB is 2/3, and the slope of BC is -2. Find the slopes of CD and DA if it's a parallelogram. Well, if it's a parallelogram, remember now, ABCD has to be drawn in the right order, right? So ABCD. So AB is parallel to what? CD. That's right. So AB and CD have to have the same slope. So it's what? CD is 2/3. And then the other one would be what? DA, which would be what? -2. All right, is everybody happy with that? Any questions? Chancellor, you're good? Right? Boys, you guys, Mars is a big one now. All right? If you're close, one way or another, it could go the other way. What?
It says that the slope of BC is -2, and you have -2 on your AD.
Well, because AD and BC are the same. Right? Good question. Yes, ma'am.
I don't see any answer to the question.
It's asking what's the slope of CD and DA.
Oh, okay.
So CD, you with me? Because BA, I drew it up there for one purpose. So you could see what lines, with what lines. That's all. All right, doesn't matter how I draw it. It makes no difference. All right, you draw it for perspective to make sure that you have what corresponds to what. All right, so if this is a rectangle, what's true about those two angles? I don't think so, guys. Come on, someone help them out.
Oh, of those triangles?
I'm looking at this angle.
They're equal.
Do you agree they're equal, right? Now again, the main thing again, I'm trying to tell you is that you're not going to remember all the rules. Does everybody understand what I'm saying? There's so many rules, right? I would want you to just be able to look at that and say, okay, we have a rectangle, right? If I draw the diagonals, what looks true about the diagonals? They look equal, but we could prove that easily. And then the diagonals look like they bisect each other. Bless you. So that means that those sides are equal, which just makes it isosceles triangle, which means those angles are equal. So we all coming up with x equals what? 26, right? X equals 26, right? Now, they're asking about angle 1. All right, so don't put 26 down. All right? So 26 times 2, 52 plus 10, 62. So 90 minus 62, 28. I think that's the way you should be thinking about these problems. All right? Quick.
Sorry, how did you get 62?
I multiplied, substituted in for x.
Oh, yeah, sorry.
What? William?
No.
All right, good. All right. The diagonals of a rhombus intersect at E. All right, so again, are the diagonals of a rhombus equal?
Yes.
Now remember, the easiest way to think about it is here, and then if you start to tilt it, one diagonal gets what?
Longer.
Yes, that's how I figured it out. The diagonals are not equal, but they are what? They are perpendicular. All right? So if you try to draw something accurate as best you can, and I draw that so it's kind of right, does everybody see how it kind of looks like it's what? It looks like it's perpendicular. Do you agree? All right. So that's how I would like for you to look at it. So now I'm going to say the diagonals of a rhombus. So A, B, C, D. Here we go. All of those are equal. And then I like to draw my right angles. And if you want, you can say they bisect each other. So that's what we're dealing with. So what looks true about all of those triangles? All the triangles are congruent. All right, by side, side, side. That's an easy thing to prove. All right, easy thing to prove. All right, so now they're saying BAE. So where is angle BAE? So I'm looking at E is the middle. Thank you very much. So I think BAE is this guy right here, right? And then angle BAE is 2/3 of ABE. So if this is X, right here, then this guy down here is what? 2/3 X. That's what I'm thinking of. That's the only thing that comes to my mind right now. Or I like to label things so it makes sense. Or I'm not even sure that's accurate. Or I'm not sure that's accurate. It says, find the measure of BCD. Okay, I think we can do that.
Oh, yeah.
Right. Now, again, these two angles, very good. Those two angles that I just listed, 2/3 X and X, have to add up to what? 90. They have to add up to 90. So hopefully you could tell me what 2/3 plus 1 is.
It's 1.
Which is 5/3 X equals 90. Everybody happy with that? You don't know 1 plus 2/3? Okay. What? Shh. I'm listening. Go. Come on.
Okay, I'm just confused on how and why.
I'm asking this. This is all I'm asking. It's going to sound kind of funny when you was asked Miss Stern here. If I say 1 plus 2/3, you're asking me how did I get 5/3?
No. I understand that, but where'd you get the one why?
Because I'm trying to figure out this angle. That's a very good question. I'm trying to figure out BCD. So BCD is this angle. Do you agree? Which is the same as this angle. Do you agree with that? So if I figure out what this angle is, multiply it by 2, and that's the answer. Here, hold on a minute. Do you understand that?
Well, I understand like why the number.
Okay, why the number 1 right here that I wrote down? This? Because there's 1x. So I'm adding 1x plus 2/3 x.
Oh. Now, wait. I don't understand then why is there still an X at the end?
Why is there still an x at the end?
5/3 X.
Because 1x plus 2/3 x is 5/3 x.
Okay. And I'm gonna look really stupid.
That's, you know.
I don't understand how you got 5/3.
Okay,
You
so
said 1 plus
1 is the same as 3/3.
Yeah.
3/3 plus 2/3. Go.
Why is
Where'd
it?
you get, so like, where'd you get the X that you put in the?
Because I have no idea what that is. I just know that BAE is 2/3 of that. Very good question, right? Do I have any idea what ABE is? That's why it's X. I have no idea what it is. You hear me? Right? So I can make a relationship with the other one by saying it's 2/3 of that. Okay? So when I solve that now, 5/3 X equals 90, I end up with what? Right, which is, I think 54. So let me check. What?
So are you saying angle CAD?
I'm not saying anything about an angle. I'm just saying
Is
X
angles-
came out to be 54. Is that correct?
18 times 3. What's
Yes, 54.
Is angle CAD 1x?
CA what?
D.
Why do you think that?
Because you said you added angle BAC with angle CAD, and that is equal to angle
I'm not, you're just saying things now. All I'm doing is telling you, come on, please help me out here. This is x, this is 2/3 x. Those add together are 90. That's all I'm saying.
Okay.
That's it.
I get it.
Right? Now I figured out what x is. X is 54. So if x is 54, stop. If this is 54, this is 54, which makes that angle there 108, which means this angle over here is what? 108, because they're equal. What?
Don't check it. It's 2/3 versus 54.
Oh, dang it. Yes. Thank you. 2/3 of 54, which is 36. Thank you. Thank you, thank you. So please pay attention now because I messed that up. Here we go. One more time. Right, I found x to be 54, correct? If x is 54, this angle right there, Joe, come on. 2/3 of x. Did I see that? William, shh. You see what I'm saying, William? All right, so do you understand how I got 54?
Yeah.
So now I'm going to go slow. All right, shh. X is 54. You hear me? So if x is 54, this angle right here is 2/3 of x. So 2/3 times 54 is 36.
Oh, and then you also know about 2.
This is
So
36, therefore this is 36, which makes this angle 72, which is the same as this angle over here, 72. Quickly, come on.
Do the diagonals bisect?
Yes, very good. Now, listen, another very good question, because tomorrow I promise you I'm going to just ask specific questions. And I don't want you to go home tonight and try to memorize all of the answers. So she asked me a very good question. Her question was, do the diagonals of a rhombus bisect the angle? Now, let's say we forget tomorrow. Watch. It's a rhombus. So this is equal to this, correct? And this is equal to this, correct? So if I draw the diagonal, the top triangle and the bottom triangle congruent by side, side, side. Right?
Yeah.
So now this angle is congruent to this angle by CP,
Okay.
right? And so because this angle is equal to that angle, that diagonal bisected that angle. You with me on that? All right. So that's how you can kind of figure things out. All right? For those of you guys who just want to look at all the rules and memorize all the rules, have at it. All right? What?
It bisects the angle, but does it bisect the other diagonal?
I don't know what you do. You mean does it cut this in half?
Yeah.
Yes, it is.
That's perpendicular.
It's
I
perpendicular.
understand it's
And this is equal to this.
Okay.
Because it's a parallelogram. Listen, this is where we're trying to put it all together. Automatically in a parallelogram, the diagonals bisect each other. So a rhombus is a what?
Oh, yeah, yeah.
The rhombus is a parallelogram. That's the other thing I'm trying to tell you, is that all of the properties that we know for parallelograms also apply to a rhombus. So in a parallelogram, we know that the diagonals bisect each other, so you can mark those equal and you can mark those equal. That's how you can quickly prove this triangle is equal to this triangle up here now. All right, it's very easy to do. All right, and like I said, I would prefer that when you take a standardized test, especially in geometry, that if you just look at shapes, you can figure everything out. All right, you can figure everything out. All right, so I feel that was pretty productive. All right, let's go to the next one. All right, the diagonals of a square intersect at E. If AE is 2, find the perimeter. All right, low battery. What is low?
Isn't it what? It says
Shh,
that.
shh, shh, shh.
I'm not- it says 100%.
No, I know, but just, all right, so it could be my pencil, it could be lots of things. All right, so drawing your square, right? Now, if you draw in your diagonals, what looks true about the diagonals? They bisect each other. Yeah, exactly correct. So essentially what's happened is that the diagonals are equal and they bisect each other. So all of the triangles there are congruent, right? And so if AE is 2, then this right here is 2. Does everybody agree with that?
But then we automatically elect.
That's right. But what is the length, what is the side of the square?
Oh, Pythagorean theorem.
That's right.
So
Now remember, here's what I'm telling you guys. Try to do this for me now. I'm going to try to show you something that'll help you. Do you agree it's the square root of 4 plus 4? Right now, no. But listen to what I'm saying. So there are two 4s. Does everybody agree with me? That's how I would want you to look at that. There are two 4s. So that's 2 radical 2. That's how you should be doing it. All right? It's easier that way. All right? So the perimeter would be what? Times 4. So that'd be 8 radical 2, right? 8 radical 2.
So like see how you put it outside.
All right. Exactly. All right. So I really want to go down to the proof real quick, guys. All right, I want to go down there. I feel like if everything I haven't finished making the test. It'll be fair as always. All right. So here we go. Again, if we're writing out this proof, all right, it's a rectangle. Do you agree? So if it's a rectangle, then all of the angles are 90. So that's what I would do right off the bat. And it says that GC is equal to HE. I'm trying to prove that FG is congruent. Man, everybody agree that's kind of easy, right? Because why? Because it's a rectangle. Because it's a rectangle, what's true?
The angles are equal.
I know, but what side specifically?
DE.
DE, thank you. So I would mark DE congruent to CF.
So it's side angle side.
That's right. Come on, guys. It's really simple. It's really simple. Really simple. No excuses. All right? So again, the statement would be given CG is congruent to HE and it's a rectangle. But you can't just say side, angle, side. You have to say that angle C and angle E are right angles. Does everybody hear me? Listen to what I'm saying now. The angles are right angles because it is a what?
Rectangle.
It is definition of a rectangle. Then you have to say angle C is congruent to angle E because all 9-degree angles are congruent. Is everybody with me on that? Right? 9-degree angles are always congruent.
Can you do angle side angle?
Well, what other angle do we have?
Angle C, line CF,
No, look. What angle is that congruent to and what angle is that congruent to? You see what I'm saying? I can't really see that. Do you hear me? How am I proving that those are congruent?
I'm not saying this. I'm saying CF.
I'm trying to prove those two I'm trying to prove that this triangle right here is congruent to this triangle right here.
Yeah.
So what other angles do I have? I just asked.
Oh, okay, I see them.
All right, thank you. All right, so is everybody hearing me on that? What?
Mark, can you just draw?
Just come on. What?
How did you get the third side?
I
How'd you
didn't get
make
a
it side
third
equal side?
side right here. Angle side.
I know. How'd you get that side? The last side.
It's the rectangle. It's a rectangle.
It's
All
in
sides are
CF.
Shh. I'm trying to get her to learn.
I'm not worried about CG. It's
Just listen to me. Stop trying to help her. You just listen to me. All right. You're asking me, how did I know CF is congruent to DE? It's a rectangle. Definition of rectangle. Opposite sides of a rectangle are congruent. You with me now? Right? So CG was given, all right, HE is given, and it's a rectangle, just like we knew the angles are what? 90, because it's a rectangle. All right, you're allowed to say that. All right, if it's a rectangle, the opposite sides are congruent. All right, and the angles are 90. Yes. No,
It's in the.
it's going to take me. And that's the other thing I was going to say. Look, it's at the bottom, right? It's at the bottom. It's in the answers. You see what I'm saying? And I just have so much to do. I'd rather, right? And I knew the answers were down there. So I walked you through it. You good? Yeah. All right. So let's try the next one. All right. Next one is very similar, correct? Very, very similar. So it's the rectangle, right? Z is the midpoint. If Z is the midpoint, then those two are equal by what? Definition of midpoint. Does everybody agree with that? All right. Now, because it's a rectangle, these angles are congruent, right? Because all right angles are congruent. Definition of rectangle, angles are 90 degrees. Then we can say that the other side is congruent. Definition of rectangle. And then we can say the triangles are congruent again by side angle side. Is everybody good? And then YZ, CP, CTC.
It's the same.
Simple thing. Simple. Simple, simple. All right? So now, the next one. All right, it's kind of annoying, a little bit longer, kind of nice. I almost erased everything. All right, but because there were so many steps in here, I just wanted to show you. All right. So now let's try to walk you through it. ABCD is a parallelogram. Obviously, that's what? Given. All right. Now, from there, it says AD is congruent to CB. Why is that? Yeah. Parallelogram. Now, I'm not really going to say that it's the definition of parallelogram, because the definition of parallelogram just says the opposite sides are what? Parallel. But we have proven that they have to be congruent. So we would just say that opposite sides of a parallelogram are what? Are congruent. Simple as that. You with me? Not definition.
Yeah.
All right. Although I'm not picky. I don't really even care. I'm just trying to, details. All right. So this would be opposite sides are congruent. And then why is PA congruent to RC? Yeah, that one is given. All right. And then it says that PD is equal to RB. Yeah, that's kind of bad in my opinion. Well,
they should probably get the triangles.
Well, that's why sometimes I don't really like doing what somebody else said. All right, but let's just talk about it real quick. All right, let's talk about it. So we know, let me put it up here for you. We know that AP plus PD equals AD. Does everybody agree? And we know that BR plus RC is equal to what? BC. And we know that we already said that AD is equal to BC, correct?
Yeah.
Therefore, AP plus PD has to equal BR plus RC. Is everybody with that? Everybody good? That's a substitution, right? Then we know that what?
You just take out AP and RC.
Yeah. Yes, but technically we would have to come over here and say that RC is the same as what? AP. Is everybody with me now? That's a substitution. And then subtraction. You would say that PD is equal to BR. Now go to the reasons. I want to see what they said, because I would not have done it.
I think you only had opposite
Oh, yeah. They didn't even, I didn't write that out, so I'm glad we're doing that. All right, so that's why they didn't. They left out some things. All right, so does everybody understand this right here now? Does everybody hear me? All right, so that now PA, so this was given right here. And then all of this should be in there. Does everybody agree with that now? Good. All right. Can't what? Well, because we're trying to prove, it's saying right now that PD is congruent to BR. How is that the segment?
Oh, no, no.
You with me now? No, don't worry. All right. I'm listening. Well, what are we substituting is my question. see what I'm saying? It's not that easy. You see what I'm saying?
So you have to explain it, even though you would know.
Yep, that's exactly right. Stating the obvious. That's what I used to tell my geometry teacher. What am I doing? Stating the obvious. All right, literally. We used to fight all the time. All right, stating the obvious. All right, so AB is congruent to what?
It's a parallelogram.
AB, hold on a second. AB is congruent to, yes, so that is, yes, opposite sides are congruent. Good. All right. So now Y is BQ. Is it? Thank you. Given. And so now they're saying A, same thing, right? You with me? So it'd be the same exact process. So AQ is congruent to CS. Everybody good with that? So now Y is angle A congruent to angle C and B. Yep, that's correct. Opposite angles are congruent. Opposite angles in a parallelogram are congruent. Do I agree with that? And then why are the triangles congruent now? Side angle sides. Do I agree? Side angle side. We said right here, sorry, this angle and this angle are congruent, and this angle up there is congruent to that angle. Can somebody see that? All right. And so then we said it was what? Side, angle, side. And then QP is congruent to, yes, CP, CTC. Corresponding parts. All right. Now, PQRS is a parallelogram.
Because all the sides are.
And I wouldn't say all the sides. That's right. Exactly. Exactly. Opposite sides.
Both pairs of opposite sides.
Both pairs of opposite sides are congruent. Therefore, it is a parallelogram. All right. So again, you can see how kind of tedious that gets. But I'm hoping. I mean, it's not going to be that complicated. I'm not worried about it at all. But hopefully you can look at that and go, yeah, that kind of makes sense, right? It's really the proofs. Hopefully you're feeling a little better about it. You know, it's just, do you know the information? That's basically it. All right, go.
This is just a question about the
Good.
last thing. Where you said both pairs of opposite sides are congruent. You said that they both had to be parallel because that's a parallelogram opposite.
Right.
But if they're congruent, that works too.
Yeah, so there's multiple ways. If opposite angles are both congruent, but we didn't prove that here, do you agree? But we did prove that this is equal, well, we did prove that this is equal to this, and this is equal to this. So one of the reasons is that. If we could prove that, and this is the question on the test, if the opposite side is congruent and parallel, it's automatically, you with me? So there are little rules that you can remember. All right, if opposite angles are congruent, then it's automatically a parallelogram. All right.
How were you able to prove QBR and
Q.
SDP? Because you only have an angle and a side. There's two.
BS and
No, because the QB is a side.
Yeah.
Like you'd have.
This right here, yeah. You see what I'm saying?
Oh, okay.
There you go. You with me now? Right?
Oh, okay, yeah.
All right. All right. So I don't know how much time we have.
Like
1 minute.
Okay. So again, listen, honestly, if you guys need to come in the morning, that's perfectly fine. I do think there's maybe, I think, 2 questions where you have to draw something out and kind of decide what it is. All right. There are questions regarding this right here. You know, which are the rules for a rectangle? All right. So if you draw it out again and draw the shapes, you should be able to see, kind of without memorizing all the rules. I would look over, you know, finding the coordinates. some algebra here, drawing things out. Those are good questions. All right. The rules, right? It's essentially, honestly, guys, yeah, I don't know if you know this, but what I do is there's like 4 forms. I give you the hard one, and I give you the easy one, and then I put the 2 medium ones on the test. All right? Everybody understand that? All right. The book comes with 4 tests. They go by levels. Are you an easy, average, above average, or accelerated? And I always give you the easy one and the hard one, and then pick from the mediums. All right, so do that. All right, guys. I don't know if that's a no.
Just try, you know, Pilates calculator on the HSBT, or we have to
I don't think so.
Okay.